Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, or DTC P0365, indicates a malfunction in the circuit no signal related to the Camshaft Position (CMP) sensor B in the Honda Accord models from 2012 to 2017. The CMP sensor B is a crucial component that consists of both a rotor and a semiconductor. Its role is to detect the position of the rotor, which is essential for determining the top dead center (TDC) of each cylinder within the engine. This detection is critical for managing the timing of fuel injection. If there is no pulsing signal detected from CMP sensor B, the Powertrain Control Module, or PCM, recognizes this malfunction and stores the DTC in its memory. The diagnostic process requires continuous monitoring while the engine is running, specifically checking for signals from CMP sensor B, which are critical for engine operation. Manufacturers recommend that any detected fault in this system be promptly addressed to avoid further complications in engine performance. To prevent the occurrence of DTC P0365 in the future, establishing a routine, preventive maintenance schedule is highly recommended. Regular inspections of the Camshaft Position sensor B can greatly enhance its longevity and operational reliability. During these inspections, it is essential to check for any debris or dirt accumulation that could affect sensor performance. Furthermore, maintaining clean and secure connections can prevent electrical issues from arising. Keeping an eye on engine performance also aids in early detection of potential problems. Unusual symptoms should be investigated immediately. By adopting these preventive strategies, you can help ensure your Honda Accord operates smoothly and efficiently, minimizing the risk of future DTCs. In conclusion, understanding the role of the Camshaft Position sensor B is crucial for diagnosing DTC P0365 effectively. The sensor is integral for fuel injection timing, and any failure can lead to significant engine performance problems. By identifying the various possible causes, such as wiring issues or sensor malfunctions, you position yourself to conduct thorough diagnostics appropriately. Troubleshooting involves a systematic approach, ensuring you check both the sensor and PCM functionalities. The final steps, verification of repairs and preventive maintenance, are equally important to ensure ongoing reliability. Maintaining transparency and vigilance throughout this process can lead to enhanced vehicle performance and reduced downtime in the future. The Camshaft Position sensor B is a vital part of the engine management system in Honda Accord vehicles. Its primary role is to monitor the position of the camshaft, converting changes in magnetic flux within its semiconductor into pulsing signals. These signals are then sent to the Powertrain Control Module (PCM), which relies on accurate data to control fuel injection timing. The sensor is typically located near the engine's camshaft, ensuring proximity for accurate readings. If the sensor fails or if there's a disruption in its wiring, be it in open circuit, short to ground, or failure of the sensor itself, it will prevent signals from being transmitted to the PCM. When this happens, the engine may struggle to operate efficiently or fail to start altogether, making it crucial for this component to be functioning correctly at all times. There are several potential causes for the DTC P0365. A primary concern could be that the CMP sensor B TDC line is open, meaning that the electrical connection needed for signal transmission is interrupted. Another possibility is that the TDC line is shorted to ground, which can lead to erratic sensor readings or a complete absence of signals. Additionally, issues with the CMP sensor B power supply line being open may prevent the sensor from receiving the necessary voltage to operate correctly. Ground line disconnections can also hinder the sensor's performance, as proper grounding is essential for consistent operation. Other causes may include malfunctions within the CMP sensor B itself, rendering it incapable of transmitting data. Lastly, internal failures in the PCM could lead to an inability to process or recognize the signals from the CMP sensor B, warranting further investigation. The symptoms experienced with DTC P0365 can significantly affect the vehicle's operational efficiency. One of the most immediate symptoms is that the engine may not start at all. This is directly tied to the CMP sensor B's function in determining the timing necessary for fuel injection. If the PCM cannot receive signals from the CMP sensor, it fails to manage fuel delivery appropriately, resulting in a non-start condition. Additionally, if the engine does manage to start, it may exhibit a rough idle, meaning that the engine's RPMs fluctuate erratically. This instability can lead to a jittery driving experience and may even cause the vehicle to stall during operation. Furthermore, drivers may notice poor engine performance, such as a lack of acceleration or power, which can be detrimental for both everyday driving and highway conditions. The first troubleshooting step for DTC P0365 involves checking the wiring associated with CMP sensor B. This includes thoroughly inspecting the wires for any visible damages, such as frays, corrosion, or breakage. Since the sensor relies heavily on electrical signals, it's crucial to ensure that all wires are firmly connected to avoid signal interruptions. Testing for continuity can also reveal any hidden issues within the wiring. Additionally, ensure that there are no loose connections at the terminal ends of the sensor and its corresponding connectors. Making certain that the wiring is intact and free of faults creates a solid foundation for addressing this DTC effectively, as damaged wiring can often be the root cause of signaling issues. The second step in troubleshooting DTC P0365 is to examine the CMP sensor B itself for potential faults. This includes checking its physical condition, as any visible damages can indicate a failure. To ensure the sensor is functioning properly, testing its output voltage with a multimeter can provide insight into its operational status. Compare the readings against manufacturer's specifications. Any deviations might signify that the sensor is defective. Moreover, a visual inspection should be performed to ascertain the integrity of its housing and the alignment of the rotor. A malfunctioning CMP sensor B can lead to incorrect signal transmission, making it vital to confirm its effectiveness before proceeding with more complex diagnostics. If the CMP sensor B appears to be functional, but the DTC persists, the next step involves checking the connections to the powertrain control module, or PCM. Verifying that all connectors are secure and free of corrosion is crucial, as poor connections can impede the PCM's ability to receive information from the CMP sensor. Following the visual inspection, a more extensive test involves checking for any internal failures within the PCM itself. This can be established using specialized diagnostic tools that communicate with the PCM to retrieve fault codes or operational data. Testing the functionality of the PCM is particularly important, as an internal failure could be the reason the sensor's signals are not being properly acknowledged or interpreted. Once all potential issues have been addressed, clearing the Diagnostic Trouble Codes, DTCs, with an automotive scan tool is the next crucial step. This process refreshes the system and allows you to monitor the vehicle's performance without the interference of previously stored error codes. After clearing the DTCs, it is essential to conduct a test drive to observe whether the fault reoccurs. During this phase, monitor the powertrain control operations and be alert for the MIL or malfunction indicator light to ensure that it remains off. This step is imperative, because if the DTC resurfaces within a few drive cycles, it indicates that a persistent issue remains, requiring further troubleshooting and intervention. After completing the repairs and troubleshooting for DTC P0365, it becomes essential to conduct a final verification. Start by confirming that there are no remaining diagnostic trouble codes present in the PCM. This ensures that the root issue has been successfully addressed. Following this, monitor the engine performance closely. It should operate smoothly without any irregularities such as stalling or misfiring. Additionally, ensure that the vehicle starts without any issues and maintains a steady idle. Lastly, conducting a short test drive while monitoring for any warning lights is advisable. If the vehicle exhibits consistent performance without re-triggering the fault code, the repair can be considered successful. Please like and subscribe to the channel. See you next time!